In this tutorial, we want to learn a little bit about what conjugate acid-base pairs are and how they form. So if we take a look at figure 1, we see that by definition a conjugate acid-base pair involves two substances that differ by a single proton. So in this equation up above, there are actually two examples of conjugate acid-base pairs. We've got HS- and H2S, which are a conjugate acid-base pair because the only difference between them is a single H+. And then we have HF and F- are also another conjugate acid-base pair. Note that with the first combo, the HS- and the H2S, the HS- is acting as the base out of the pair, whereas the H2S is acting as the acid, and this is because the H2S is a better proton donor than HS-, and conversely, HS- is a better proton acceptor, which makes it a base than H2S. And the same idea applies with the HF and the F-, that the HF is the acid of the pair. It's able to donate protons, and the F- is able to accept protons. And if we just focus on the reactants for a second here, we see that the HS- between the two reactants, the HS- is the base because again it can accept protons. And one sign of something that is capable of accepting protons is that if it has a negative charge. That's not to say that all negatively charged ions are proton acceptors, but certainly something is a better candidate to be a base if it is negatively charged, because it will be able to accommodate the extra positive charge that a proton brings. And likewise, in order for something to be an acid, you know that it needs to contain at least one proton, and so HF fits that bill. And between these two, HF is the acid because it is a better proton donor than the HS-, and the HS- is a base because it is a better proton acceptor. And in figure 2 here we see that all of the substances that are basically beside one another, so for instance the NH4+ and the NH3, they're all conjugate acid-base pairs because they all differ by a single proton. And in each case you see the thing that has a proton or has more protons, in the case of something like H2SO4, which can have multiple protons. The thing that has a proton or more protons is the thing that acts as the acid, and the thing that has a negative charge or is less positively charged is the thing that acts as the base in each pair. And we'll talk a little bit more in later tutorials about this idea of the acid strength and the base strength, and kind of what are some of the what that all really means. And so really the focus in this tutorial was on conjugate acid-base pairs, determining what they are, and so we see that they are pairs of substances that differ only by a single proton, and being able to identify examples of conjugate acid-base pairs both in chemical equations and outside of chemical equations.